Hello friends, welcome to Secret of Electronics. In this video, we will learn how to control multiple LEDs using a rotary encoder with a Raspberry Pi Pico board and the Micropython programming language. In this circuit, you can see that the 3.3 volt output pin of the Raspberry Pi Pico board is connected to the VCC pins of both the 040 rotary encoder module and the SST1306 OLED display. The CLK pin of the rotary encoder is connected to the GPIO pin 16 of the Raspberry Pi Pico board, and the DT pin of the rotary encoder is connected to GPIO pin 17 of the Raspberry Pi Pico board. 5 LEDs with 220 ohm current limiting resistors are connected to GPIO pins 2, 3, 4, 5 and 6 of the Raspberry Pi Pico board. The STA and SCL pins of the SST1306 OLED display are connected to GPIO pins 0 and 1 of the Raspberry Pi Pico board. This Micropython code is for controlling 5 LEDs using a rotary encoder and a Raspberry Pi Pico board with feedback displayed on a SST1306 OLED display. It uses the Micropython programming language and SST1306 library to communicate with the OLED display. GPIO pins 2, 3, 4, 5 and 6 are defined as outputs for controlling each LED. GPIO pins 16, 17 and 18 are used as inputs for the rotary encoders. CLK clock, DT data and SW switch pins with pull-up resistors enabled to maintain a stable input state when inactive. GPIO 0 and 1 are used for the I2C communication with the OLED display. The OLED display is initialized with a 128 by 64 resolution connected over I2C. A current underscore LED variable tracks the currently selected LED, and toggle underscore states is a array to keep track of each LED's on and off state. The update underscore display function updates the OLED display with the current LED selection and its state on or off. The update underscore LED underscore selection function detects rotation by monitoring the CLK and DT pins. If the encoder rotates forward or backward, determined by comparing the CLK and DT values, it increments or decrements the rotation underscore steps variable. Once rotation underscore steps reaches a set threshold, 3 steps in this case, then the current underscore LED variable is updated to select the next or previous LED, cycling between 0 to 4, representing the 5 LEDs. The toggle underscore LED function toggles the selected LED's state when the rotary encoder's button SW pin is pressed. It changes the state in toggle underscore states and updates the OLED display to reflect the new status. The main loop continuously checks for encoder rotations and button presses. When a button press is detected, it toggles the state of the currently selected LED, and a small debounce delay prevents multiple reads from a single press. Additionally, there is a brief delay in the loop to ensure smooth operation. Now connect the Raspberry Pi Pico board to your PC using a USB cable. After connecting, open Thony IDE and save the code files to the Raspberry Pi Pico board without changing their original names. You can download the code files from the link provided in the description. Now you can see that I can select the LED by rotating the rotary encoder. After selecting a LED, when I press the rotary encoder, then the corresponding LED state changes or toggles.